All right. Good evening, everyone. It is 6 o'clock. Oh, there we go. That's best. Good evening and welcome to the Houston Azure User Group. Think about it, August edition. Good to see everyone. Thanks for coming out. My name is Adam Hems. My day job is a cloud architect for Microsoft, so I do Azure all day, every day, and have done since 2015, I think. All day, every day. Yeah, pretty much. I was at the launch of Azure in 2010. That was not that. It was okay. Well, anyway, so Azure's got a lot better over the years since then. I've been working full time with public cloud since 2013. So I've seen a lot of customer journeys as a professional, and the journeys are, as many of you know, pretty similar because the technology is essentially the same, even if you go between the major cloud providers. And I took over the lead of this group in 2015. So who's new to this group today? Any newbies? So at least a couple, a few folks. You got the newbies are sat at the back in the far corner over there. I suppose right here. No, I'm just messing with you. Warm welcome to the noobs. The focus of this group, or the reason that I wanted to, I'm passionate around it, but it's really a hobby of mine, is because it's an opportunity for us to learn from one another. So we have here in Houston a huge array of usually oil and gas, any oil and gas folks, or at least in the energy, touched by indirect folks. Yeah, kind of. Yeah, I work with oil and gas, not necessarily for oil and gas, but with or to. Yeah, that happens a lot. Any healthcare? That's another one we see a lot of. Healthcare as well. Okay, that's used a lot of government folks. We see some government folks. Not today. But we've seen school and government folks have been out here. And then we have different technical specialties. Developers in the room. Okay, a few developers. Yes, developers representing. Awesome. Good to see you guys. Welcome. I have a developer background, Slum coding for over a decade. It was fun. It was good. I still write a little bit of code, but much more, not for fun now. Yeah. So infrastructure folks, more data-centric folks, maybe database folks. I think infrastructure is like this. Yeah, the devs are all like, infrastructure is like, yeah. Loud and proud. Yeah, I'm infrastructure, right? Yeah, It's all good. I'm just bossing around. Folks, databases, database administrators. Okay, a few of those. There we go. Waving hand. There's Mike. Right. There's so a variety. So the point of sharing that, right, is that we have a lot of different experiences from folks in the room. And students, we often have students. We've had that, but none today. Okay, students are welcome. Had some go to learn, right? We're just still in school. We've had professors at like the U of H send their students to this meetup so that they can just come and learn from more experienced folks or just from the presenter or both, right? So the intent of this is to, an opportunity to learn from different folks in different industries with different specialties, perhaps using pretty much the same technology. It's not special technology for one, industry or another. Part of the Gulf cloud are separate, but for most of us in here, it's the same set of technology. We're using it to solve similar business problems. So an opportunity to learn is the intent of this. It's not a sales pitch. So I'm here for a sales pitch. Wrong route. Not today. Not doing that. That's just specifically what we're not here. Or it's just an opportunity to learn. And the presenters we've had, many of them are colleagues of mine. They have a particular technology that someone's passionate around. I've allowed myself the opportunity to present a couple of times, but I have to contain myself because, give others a chance, which is much better, I think. Presentations as well. Some of my favorites are when we've had members of the community present as well, which is actually what we have tonight. I'm pleased to say, members of the community presenting about things that they've learned. So the intent, I hope, is that everyone will learn from our presenters tonight, from each other. We haven't had a chance to have some pizza. With that, speaking of which, that was also the presenters that were kind enough to sponsor the pizza. So thank you for these guys. Pull that out. And with that, tell them about ourselves, Dave.
Thank you. Thank you, Adam. Yeah, and help yourself to pizza. Feel free to get up as much as you wish because there's a lot of pizza back there yet. My name is David Kent and I'm president of David Kent Consulting. I'm sure that no one in this room has ever heard of David Kent Consulting before. There's a reason for that. It's because we are a very narrow niche business. So for the past 22 years, we have been providing IT, technical and functional services to institutions of higher education, primarily supporting the infrastructure, the environments that support the business activity of these colleges and universities. The newest company that we have, Kent Solutions, is a spin-off of David Kent Consulting. Hank Wojteczko, this main speaker tonight, is our lead cloud architect as well as our cloud practice manager. He came on board about 5 or so years ago to lead our cloud practice. And at the time, many of our clients had been wanting to move to cloud, and no one knew how to do it right. And came along with our and as the father of our unique approach that takes and re-architects these institutions' environments to be cloud native. Lots of infrastructure as code, containerization, lots of security things, and so on. So I think one of the most recent projects that we have is a multi-cloud solution that we began, how long ago, Hank? About 3 months now?
Well, we started talking about it 2 years ago.
Yeah, so a very large East Coast institution. We have decided that they want to run the applications here in Azure, and they want and they leaned on us to help them make that work.
What's OCI?
Oracle Cloud Infrastructure, the Oracle, yeah, the Oracle Cloud. So I'm going to turn it over to Hank here. He's going to be talking about this adventure, the latest adventure here. So it's a very much a first for higher ed to be multi-cloud, especially with Azure and OCI together. So we're happy to be first to market with that. All right, I'll turn it over to Hank. Tell us all about it now.
Thank you. I would tell you that, I was just telling the story a couple of times today that when I came in here in 2018 to this group, and I saw someone from Exxon talking about microservices, Azure DevOps, infrastructure as code. I said, ooh, I better learn how to do all that. And I did. It was hard, but I did. And you can too if you're not there yet. And that really is the most important foundation to learn. This is good. This multi-cloud stuff is good. And this integration that you're seeing that's beginning, we've got remote people, so I'm gonna walk over here close to the computer so people can see me. And thank you for anyone who's attending remotely. We need to have multiple clouds integrated into the enterprise. And the reason why we need that is we need to be able to, as consumers of this infrastructure and these software services, we need the best of breed for solving tough business problems. And we need to do it in the most practical, efficient, and affordable manner possible. Because when it gets down to it, although the tech changes at a lightning pace, we have to deliver value, and we have to deliver value to the business process and to the business value stream. And sometimes building everything on one cloud is not going to deliver value in the most efficient way, especially when you talk about expensive software applications like Oracle Enterprise database or Oracle Extreme Edition, Oracle Exadata, and you crunch the numbers and you look at how these products are bleeding cash out of your IT budgets, and you want to get more efficient, you want to drive down that cost, drive up the performance, drive down the bottom line cost, and increase profit for your shareholders and your stakeholders. And multi-cloud may be a right fit for organizations who need that really high performance kick and also need to find a way to save on the cost of, say, doing on-prem with the data center, the cooling, the generators, the Exadata frame. By the time you add the fiber channel switches, you add all that up, and it gets expensive pretty quick. And for me, when I crunch the numbers,
Anybody else lose audio? Lost audio here. It's showing you as muted, Hank.
okay, can you hear me now?
Yes.
Okay, so what are we talking about? We're talking about Oracle Database Services for Microsoft Azure. What is that? That is some really super duper fast networking at colo facilities in various regions throughout the United States, Canada, Asia, and Europe at key ingress points into these cloud providers where Azure and Oracle are peering their networks together with very high speed, ultra low latency network switches with very short distances from the colo facility to the actual regional data centers themselves. What does that equate to? That equates to from endpoint to endpoint. And what I mean from endpoint to endpoint is from database service, whether it's Exadata in the cloud or virtual machine database or combination of that, to Azure Kubernetes services or AKS with a pod or an application pod or a group of apps running as a pod are running an ODBC client on them with an Apache front end. That the latency between these endpoints, nominally speaking, is 2 milliseconds with peak latency of 4 milliseconds. And this is between two different cloud providers with the database under duress. That's incredible. Now, let's see if I can advance this without blowing up the audio. This is the Microsoft slide, but when I do presentations, I go off script all the time. I like to go off script. What are the challenges that we face when we're running Oracle on-prem and we want to run our application tier, we want to move it up into the cloud? And we have a very high speed network that exists between our on-prem network, where we have the Oracle database, and the application tier that we're firing up in Azure. What we have is a mathematical problem of physics called long fat network, or LFN. If you do a Google on LFN with Encyclopedia boom, it'll pop up and you'll see the math that calculates that. Basically, it's a TCP sliding window nightmare where the client is receiving ingress connections from customers, and that data stream is being multiplexed by the TCP streams process. And it then flows into the long, meaning geometrically long, BAT, holding lots and lots of data network from the ingress point for the application to the database server. And what happens is that Tomcat engine is just pumping the data. I've got 250 concurrent users. I'm going to slam your database and you're going to keep up with it until the TCP window fills on the database server. And this is a classic sliding window problem. I was first exposed to it in 1996. It's how long this stuff has been around, when I was working on a project with JP Morgan. So the math hasn't changed. And so what happens is the window fills up on the Oracle database, which is nothing more than a TCP peer, and it sends a TCP reset and restart at sequence 100. But in the meantime, I've got 101 to 2000 sequence numbers in transit from this client to this database server, and that all gets tossed out. And then the Tomcat application dutifully restarts at 101, and then it repeats itself. And what you end up getting is an application that is super duper slow. And customers who try to move their app here to the cloud on high-speed links and still have that Oracle database on-prem, they will occur. This problem will occur, and it will occur because it's a mathematical probability. Now, there are products like Riverbed that kind of tweak things and do caching, and they muck with sliding window with their special sauce. That's an expensive product, and it is not solving the problem of the physics. It's kind of masking over it. It's kind of crutching through it, but it's really not solving the problem. To solve the problem, you've got to get your database and application tier in close physical proximity to each other. And for those of you who raised your hand and said, I do infrastructure, I used to do it, infrastructure, I used to be a storage engineer. And so the geometric distance for optimal performance of an application, of a client server application with Oracle database is no different than the geometric, the geometric distance that you would have from say, doing synchronous SAN volume replication. So it's like 80 clicks. You don't want to go over 80 kilometers. You go over that distance and you're going to start to have the problems of physics, and LFN will come into play. Now, another thing that is problematic with going to the cloud is the Oracle license agreement for Oracle Enterprise, High Performance, and Extreme Edition. It's not as bad on standard, but you really can't do much with standard edition. If you're running enterprise applications, at the very least, you're on Oracle Enterprise Edition, if not more. And so the licensing agreement per CPU, per proc, that's physical proc, not virtual. So in Azure, you're thinking vprocs, but in Oracle Cloud, you're thinking pprocs. And when Oracle licenses this stuff, they've been tweaking that licensing model, so the odds have been financially in their favor for license revenue for a long time. But they've kind of hit the wall on how far they can take that now. It's one physical proc, $47,500 to purchase that proc license, plus the maintenance, which is typically around 18 to 22% per annum starting the second year of the license purchase. That's a lot of clams. That's a lot of profit getting eaten up by software licensing. And so how do we solve that problem when we are not permitted to take a campus agreement where we are licensed based on our full-time employment model, because there's that license option too. So as our employment goes up, our license costs go up, but we can take those licenses with us to the cloud for 1 period. That's what the agreement says, which means, or for the term. And what is the term? Well, there are 5 terms in a 5-year contract. So that's basically the first year. So if you're 9 months into your first term and you've completed your migration to the cloud, and you've done 100% AWS or 100% Azure, the Oracle, we call them the Oracle licensing police. Everyone who's in an Oracle shop has seen this before. The Oracle police come over and say, well, you have violated the terms and conditions of your agreement, and you owe us $8 million. Because you've got to replace, you violated the agreement, and you also have to buy $7 million of Oracle Proc licensing because your campus agreement is no longer valid. Oh, that's not good. No, that's not good at all. My boss will be very unhappy with that. So these are the 2 big problems. If you reduce it down to what the technical problems are, long fat network is it's a mathematical problem that describes the physics of the data going through the fiber optic cable, and the accounting problem that your CFOs are quite experts at, and we are not as technologists. So what does the new service give us? It gives us a real sexy way to integrate Azure and Oracle Cloud. So if you're an Azure shop, you can use the Azure Resource Manager to provision Oracle and deprovision Oracle databases. That is cool stuff. Just go into the portal and do it, and it's done. Or write some Terraform code, and it's done. Well, I haven't done the Terraform code yet. I haven't looked at that, but I'm told that's coming. And so you see on the left, on the right-hand portion of this presentation, you've got the very robust Azure business, developed for business to business, people like us, applications like AKS. I love AKS. And then on the right, you see autonomous database, Exadata in the cloud, and you see virtual database. I think the announcement had that termed incorrectly. So in this presentation, I corrected it. It's called virtual database, which is the Oracle database as a service running on a virtual machine. Now that might sound slow. Well, let's say you've got 8 procs, 128 gig on AMD as a virtual machine database, and you're pumping 384 megabytes a second throughput to the disk with a latency of 0.75 to 1.75 milliseconds to storage. That's not slow. That's really fast. Virtual machine database can kick butt. If you go beyond 384 megabytes, then I guarantee you're looking at Exadata in the cloud. But what I'm going back to what I originally said, why do we need multi-cloud? Because we need the best of breed from each cloud provider to solve business problems. IT should not exist for the sake of IT. We exist to solve business problems and add value. That's why we're here. And multi-cloud in the right situation adds a lot of value. Where does it run? Well, this picture, we're going to talk about caveats in a little bit, but this picture pretty much sums it up. It's surprisingly accurate. So in the US, you've got San Jose, Phoenix, Ashburn. Canada, you've got Toronto and Montreal. Montreal is the newer region that's coming up with the multi-cloud. So not everything is there yet, but pretty soon it'll be full blown. But you can see elsewhere around the globe that there's quite a bit of multi-cloud going on. Why would I care about that? Because if I used to work for an oil and gas company, and we had that. I don't work for them anymore, but they've got, and they're still here, and they've got operations across the globe. And when the sun moves and workers in the United States are going to sleep, workers somewhere else are starting their day. And the work on upstream research and development of new oil and gas fields does not end. It's 24/7. So the support has to move with the sun, and your microservices applications move with the sun. That also should suggest to you, well, the geometric problem, that's elephant, is that still there? Hell yeah, that's still there. So now you're also dealing with things if your database needs to be present in more than one geometric location. Now you definitely are in the extreme performance edition. You're doing data guard replication. You're doing it asynchronously. So you might be a few seconds behind from one region of the world to another region of the world, but your data is replicating. The database is open in every continent that you're doing business, and the speed, the performance is better than what they're going to get with an on-prem solution with Riverbed. And this just torpedoes Riverbed to the bottom of the ocean, performance-wise. So here's a screenshot of one of the things that you can see from the ARM, the Azure Resource Manager. So I think here we are looking at, so I don't know. Oh yeah, we're actually looking at the virtual machine database, and we can see from Azure how that database is performing. Yes, you're going to still have OEM now rebranded to Cloud Control running in Oracle Cloud. That you still need OEM, but fortunately the licensing is more attractive in Oracle Cloud for database because you get the performance and diagnostic pack with Enterprise Edition. You don't have to pay a bolt-on price for that. I hear money being saved out of my budget. I like that. So from a high-level perspective, you've got a bunch of RBAC policies that get set up in both Azure and OCI. This is the most difficult part of the glue, to get what we call the automatic method to work. There are advantages of the automatic method, and then there's the manual method, and the manual method also has advantages. And conversely, there are disadvantages with either approach. We're going to touch on that shortly. But basically what happens is you get that RBAC set up, and then you go through the portal on the Azure side, and you go through the console. That's just the branding for the UI. So you go into the respective UIs for the cloud providers. And if that RBAC is correctly set up, then the networking will automatically build. So it will automatically build the Oracle Fast Connect to the Azure Express route. It will pick the correct gateway routers on either end, because if you do this manually, you can screw it up and have bad performance. And it will build the redundancy with the peering on either end. You still have networking to do after that when you go from those hub networks on each respective cloud. So you're going to have a hub where your gateway router is going to be in OCI, and you're going to have another hub network where your Azure virtual network gateway router is going to be, and then you're going to do your routing, your networking folks who are now networkers who are doing cloud, they're going to build the routing out from there to the hub networks. While I'm thinking of it, what you don't want to do is introduce too many hops. You want to keep the number of hops from that database to your AKS or your virtual machine to be as few as possible, because you're going to have latency within the cloud between devices, just like you have on-prem. Scotty, you can't change the law of physics. I don't know if any of you are Star Trekkies, but I'm a Trekkie. I see some of you kind of smile with that. So the physics still come into play. Okay, advantages. We'll talk about the disadvantages as well. For the automatic setup, you have, in theory, a more rapid deployment. It doesn't always play that way. You have a quality assured deployment. The engineering has already been done by the programming minds, the great minds, who wrote all the code that is actually building this. I haven't seen the code, but my bet is it's really, really deep Terraform coding that's going on. You've got ARM to manage your database resources so you can provision and deprovision OCI from the ARM. And you have less setup complexity, assuming that the setup goes smoothly. When I turn over for more technical, and I realize I'm technical, but there are people who in my company who are deeper technical than I am, and Andrew is going to be talking, and he's deeper in OCI than I am. So you have less technical complexity, but again, there are setup complexity, but there are technical issues that can come up that can delay that, and you may end up doing manual, like what we did end up doing for the test bed that we're going to show you today, because we actually have this up and running right now in our cloud lab. On the manual setup, you have greater flexibility over the back-end network. This especially matters with ERP systems when you're not doing data center and region, when you're not doing region role swapping. And what a role swap is I'm running hot in Ashburn and East US, and I'm running DR in Phoenix and Central West 2, I think that is. And once a month I role swap them, and Phoenix becomes primary and Virginia becomes secondary. And then a month later, I flip that back. The role swapping is an old concept. First time I did role swapping was when I worked at Chase as an analyst. We used to role swap between the data center in New York and a data center in New Jersey. And the whole point of role swapping is you get really good at testing your DR, and you do it on a weekend. So if it blows up, you just roll it back. And then you do your corrective action report, and then you do it the following month. What does that mean? That means if backhoe versus fiber and fiber loses, and you lose access to a region and a region goes down to your services, but you have another access path to that application by way of Phoenix, well, you just roll swap and you're up and running in minutes, assuming that you are operating at either DR tier 6 or tier 7 in the 7 levels of disaster recovery. You want to be operating at tier 6 or tier 7. Okay, so with the manual setup, if you're not role swapping, and there are valid reasons not to role swap, then you can set up a different kind of a express route gateway and virtual network gateway that have a lower cost per month versus what you would do at the primary site. And that can save you $50,000, $100,000, $150,000 a year with the manual setup. And the client that we did this, that we just recently completed this for this, we looked at both. We did a prototype. We did it with the ARM, we did it manual, and they opted for manual because over the course of 5 years, they're gonna save $250,000. And they'll do their DR tests on over a weekend, one weekend a month, and then they'll flip it back during an outage window, during a maintenance window, so that they know they can do disaster recovery tests when we're done with deployment flow. You have an OCI mapping database, and you have a mapping database in Azure. And there's software complexity. I actually said it here, less software complexity. I said it twice. That matters a lot because we've seen what happens when the mapping database gets corrupt. Then you've got to open up a ticket with Oracle support, and you've got to wait for the people to respond. And even if you do a Sev1, you're still waiting. And while you're waiting, your project is stalled, and that's not fun because it just means you have that much more work to do next week. And you don't want that wait. You want your developers to be writing code, not sitting on their fannies waiting for a software defect to get fixed. So there are reasons for either approach. Now, executives at the high level at many of the Fortune 250 companies really put a lot of pressure on Microsoft and Oracle for the automated setup. They want the simplicity. But I would tell you there is not, as an engineer, there's not always a use case for the automated setup. Pick the one that's right for you. Okay, so when the automated setup has been done, you've got the seamless and interoperability. You still get that with the manual setup. It's just you set it up manually. So in either case, you get to that. But if you don't do the automated setup, you don't get the ARM integration. And that's a big minus. Now you don't have visibility from the Azure Resource Manager into OCI. So that, again, is why you may want to do the automated setup, even if it means it costs you more. To have that visibility from one pane of glass, for a lot of organizations, that means a lot. The enterprise grade cloud services, you're going to get that. And that really is the special sauce that's going on here. And with the automated setup, you theoretically don't need to relearn, but somebody in your organization, frankly, has to become an expert in OCI. You need an OCI expert and you need an Azure expert. And the two persons doing the setup, they need to be black belts. Any questions before I continue? Remotely or here? Okay, let's move on. Do's and don'ts. I think the most important thing here is to have an enterprise architecture before you start. The worst thing that we see happen is a customer signs a contract for a cloud spend agreement, and they go out and they don't have an EA. That's not a technical architecture. A technical architecture, the topology drawing and the hip bones connected to the knee bone, that's a technical architecture. That is not an enterprise architecture. An enterprise architecture are three architectures. We'll talk briefly about that with the National Institute for Health's EA, which is the best EA that I've seen out there. So you want to have an EA, and part of that EA is predicting what your costs are so that you don't sign a contract for cloud spend that is 2x what you need. We see that happen a lot, where a local rep will say, okay, here's a cloud spend, $500,000 a year, sign on the dotted line, thanks, have a nice day. Then we do our deployment, and it's costing us $284,000 a year. What happens to the rest of the money? Is Oracle going to give that back to me? No. That's why an EA is important, one of the reasons. Another reason is security. Because the information assurance architecture, which is ISO 27001.1, is brought to bear with a good, if somebody knows their salt and can walk the talk with EA, they know that framework. And there's a reason why we have frameworks, because it keeps us aligned. It's our guidepost to building applications and delivering business solutions that meet customer expectations at an expected price point. Remember, add value to the value stream. You want to predict that workload so that also you've bought enough capacity so when you go live, it doesn't perform like crap. You don't want to be undersized, especially on the Oracle database side, because the Oracle licensing in the cloud in a metered model is the most expensive part of OCI. That's the biggest part of this investment. You want to refactor the application tier for elasticity. Azure Container Services, scalable VM sets running on node pools in AKS that automatically expand and contract and are truly elastic. When we take away the marketing terms and we talk about the academic term of elasticity is for something to change its form to another form, but then to be able to automatically retract to its previous form. That's elasticity. Anyone comes in who's marketing something else, you better tell them, well, okay, the door's right there. Okay, so you want to properly size your networking if you're doing a manual deployment. There are specific SKUs if you're doing a manual deployment of multi-cloud that you must use. Otherwise, if you undersize that, your performance is going to be crap. You want to limit the use of network security devices and not have your networking group insert, say, a Cisco or a FortiGate firewall cloud appliance between your database and your AKS cluster. Not a good move. That will slow down performance and will increase complexity. Rely instead on Azure security groups that are associated with the subnet or the network interfaces. I personally prefer to do it at the subnet level. It's a lot easier. And also security lists on the Oracle Cloud side. Build for zero trust. This is really important. I spend 1 month of working time a year on the dark web because one of my hobbies is, I got 2 hobbies, queuing dynamic mathematics and white hat hacking. So I will go in and I will hack things as a authorized hacker, and I will masquerade on the dark web like I'm a black hat hacker getting ready to rent code. And I tell you, if you're not building for zero trust, it's scary because this stuff is really sophisticated. What these criminal enterprises, and they work like a global enterprise. They're just like mid-caps when you talk to them. That's how organized they are. That's what you're up against. Build for zero trust. If you're not familiar with NIST 800-207, you need to be getting very familiar with it real fast. And finally, get help from experts. It's hard when you're on the inside of a company, and I found this when I was an IT engineer with a large oil and gas company, that I wasn't doing enough of the bleeding edge stuff to be really good. And what partners bring to the table is we live and breathe this every day. We are at the bleeding edge. In this particular case, in my organization, and we actually partnered with both Oracle and Microsoft on the pilot and did one of the first deployments globally and the first deployment for a very large higher education institution. And when you're at the bleeding edge of things, you're scraping the skin off your knees. I mean, it's like football. You're really getting bruised up. But when you come out of it and you have a solution, it's so rewarding. And that's the kind of passion in a partner, and hopefully a partner who can walk the talk in Azure and Oracle. Because you need the deep and the wide bench, not just one person who can do it. We've got 7. And you need people who can do that to carry you through, to shorten the distance between the dots so that you can deliver the solution on time, on budget, meeting expectations of the customer and adding value to the value stream. I will repeat that a lot because that matters. Now, what not to do? We already talked about not starting with an EA. That is a formula for disaster. You may succeed, but you may end up with what we call reverse cloud migration. If you do a web search on reverse cloud migration, you'll see a number of documents when you get past the marketing fluff that talk about the percentiles. And the percentiles have been pretty consistent since I've been following it since 2017, which is about 47%. 40% of all major cloud initiatives that go from on-prem to the cloud have reverse cloud migrations, where either the entire application or a portion of the application is reverse migrated back on-prem and then refactored and redeployed. When you don't do an EA, this is what you suffer a risk from, and that equals time and money. And you can't put the time back into the genie bottle, and you can't replace the money when you have to go to your procurement department and increase your purchase.
Horses are my friends. I like having horses.
I'm sorry? What was that? Okay.
I think someone was off mute for a moment.
Thank you. Okay, so do not cut corners on, so you want to refactor the application. And ideally, that means you're doing microservices with Kubernetes on the app tier, and you're driving it with infrastructure as code. You're doing things like GitHub, repo, Azure DevOps, development pipelines that then trigger release pipelines with approval flows. You're using the Kanban board or some other DevOps thing to reveal all of the work and all of the knowledge to all of the stakeholders. You've got release teams and you've got release cycles running. It's DevOps. It goes fast. And part of the refactoring is refactoring the culture of your IT organization. When you go to cloud, if you do cloud like you're doing on-prem, you're picking up all of your technology debt. You're putting it on a forklift and you're driving it into the cloud. And guess what? When your project is done, your debt will be waiting for you. You've got to refactor the culture, restructure the organization, and refactor the application, and maybe refactor some of your contractors who are providing you with professional services. We're refactoring ourselves all the time. We are creatively destroying our model, always. I'm a Berkeley grad. It's something they teach you in Berkeley Business School to go through this process of creative destruction. It really matters to do this. It's how you stay vibrant and alive as an organization so that you don't die from entropy. You don't want to insert network security appliances in the middle of your application streams. And you don't want to have an open network in the cloud. I see a lot of that. We're dealing with a client right now that they have insisted they're not going to micro-segment their security. God help them when they get breached. But they're the customer. They're telling us we're going to build it like this. Okay. And try and stay away from the rookie consultants. You don't want a beginner helping you down this path. Okay, let's talk money, dollars and cents. So here is a real client. This is an Ellucian Banner. Ellucian Banner, it looks just like E1. So if there's anyone who's using E1, you know you've got an Oracle backend database. You've got a variety of front ends, typically deployed on Windows, but sometimes deployed on Linux. You've got a job submission process that's running, in the case of Ellucian, it's COBOL. I forgot the language that the job submission is running in E1, but I think they call it something different, but it's basically the same batch process to do things. So this is for Ellucian Banner, and you can see the 5-year projected spend is $1.607 million. That's a 5-year life cycle. So when we calculate this, we calculate when do I get my return on the investment? When have I made money on this? And when I make money on it, I have taken my operating budget and I have reduced it by X amount. Now, what I haven't shown you on the slide is the software licensing. The software licensing on this is $5 million on-prem for 5 years. And so here we see that, gee, it's pretty close to 5 million, isn't it, to buy Oracle Proc licenses and run it as a pure Azure or AWS play. 4.674 million. Why is it a little less? Because when we did the EA, we found all the inefficient SQL scripts in the Oracle database tuning that nobody did. And we made that Oracle database a screaming eagle on-prem. Why? Because performance problems on-prem get amplified in the cloud. You have a little more complexity up there in the cloud. It's different complexity. It replaces the complexity you have on-prem. But when you're learning about that difference, as you're learning it, that makes you scrape your knees more. So that's what I mean by problems get amplified in the cloud, because you're sailing a different sailboat, and you got to learn how to sail it. So when you start out, you want to have the team right, and you want to have that boat properly tuned. The same is true for cloud. You want to have that application and that database in particular, and all those custom SQL scripts that made a vanilla product very custom now, properly tuned. So that when I say I need $1.67 million in cloud spend, it's going to be that. It's not going to be $2.5 million. And so when do I get the pay dirt on this? In 2 years and 6 months versus the on-prem spend, it pays for itself. So I've cut the budget almost in half versus an on-prem solution with a small Exadata, Oracle database with FTE campus-based licensing. Money talks, anything else walks. This is saving money. That's why the client went with multi-cloud, for a return on investment in 2 years and 5 months. So at a high level, we can see on the left Azure, we can see on the right, these are all the major components. This was in the Microsoft announcement. And yes, our version of this presentation will be available to you. Adam, I've got to get you updates. And so you'll get the updated version because there have been some corrections since the one I sent to Adam. Okay, what is an enterprise architecture? Well, let's start with why. Why do we do an enterprise architecture? You have entropy that exists in the organization and risk. And you've got to manage entropy and risk because you have to protect the information assets. That's what enterprise architecture is all about when you boil it down to its most simplest point, is to protect the information. And you can blow up the information any number of ways, from security, human error, bad design, and cost overruns. Yeah, budget will blow things up. I've seen that happen quite often, especially in state and government. So you can see here, we've got the 4 W's of data. And that's the business architecture. You've got the information assurance architecture. If you're not familiar, I'm bad with names, but if you do a search on information assurance architecture, there's a great book that came out in 2007, and it's still a great book, and it teaches you everything you need to know about information assurance architecture. And then you have those topology drawings, the technology architecture. That is an enterprise architecture. This is what it typically looks like. So you can see we've got our primary and our recovery regions defined. Now I want to point out a caveat. When you're looking at this, you want to make sure that wherever the peering relationships exist between Azure and Microsoft, that all of the services that you require for each respective cloud provider to build your solution exist in the respective regions. For this particular client, there were some Azure services that were not yet available in Phoenix and would not be available quickly enough based on the project timeline. So, okay, we'll do San Jose and US West, and it's all good. So you can see we've got East and we've got West here. The gray you see here in the West Coast represents services that are turned off or quiesced and get turned on when you need them. We've got Oracle Data Guard running from the primary region to the secondary region, replicating those transactions asynchronously. And I'll tell you the delta on this under duress, it's about 5 seconds. Not that bad. Meaning that the West Coast is 5 seconds of transactions behind the East Coast. So we call that an RPO, or recovery point objective, of 0. And RTO is the recovery time objective. That's not when you have the tech working. That's when the business process has resumed operation. So if your RTO is 6 hours, your tech team RTO goal needs to be 3 hours, because it's going to take another 3 hours to get those people back in their chairs and working. So obviously you can imagine what happens if the primary region goes, then you're running in the secondary region. Now you see I've got Internet 2 up here. Why did I put that up here for commercial accounts? Did you know that commercial accounts, commercial companies like big banks connect to Internet 2? How many people have read the DevOps Handbook or the Phoenix Project? How many companies are technology companies? 50, 75, 90, 100%. Which one is it? 100%. Every company, including your oil and gas company, the professor teaching in a high school, everybody is a tech company, and the pandemic slapped everyone in the face with this. So, Internet 2 is something, if you're not connected to Internet 2 and you're large and you're doing research, you should be. And then this is what it looks like. What you actually have are some very high-end Cisco switches on both sides. I know it's Cisco because I know the engineer who built it, and he works for the I2 consortium, and they lent him to Oracle for a little while. His name is Bob Flynn. And so Bob told me how all the glue works. So it's a real thick trunk of 100 gig links. It's an aggregate. And a lot of the tech that goes in to make the actual code work came out of research institutions, out of tier 1 research institutions as open source products that organizations like Microsoft and Oracle commercialized. when you look under the hood of this stuff, it's open source. It's just, it's commercialized, and there's a support organization where if you need to make a phone call, there's somebody on the other side to give you help. That's part of the value that you pay for in cloud. And so this is really redundant, highly resilient. We did a lot of chaos testing on it, and we could not break it. It's very impressive. And you see DR looks identical, except when we do a manual build, which is classical for an ERP system, because typically you're not role swapping ERP systems. Because they touch so many things, they're like octopuses. They touch everything in the org, and you do a role swap, and I guarantee you something's gonna break. So you do the role swap on the weekend kind of thing, but you flip back when it's Monday and people come back to work. So in this case, we've got a standard express route gateway running in Azure. And why? Because it saves them $250,000 over 5 years. They don't need to have, they don't care about data egress because it's just 1 weekend a month that we have data egress going over it. So what? And so here's a little bit more of a view here where you've got the colo facility. You can see the switches. They are a full mesh. I don't show that in the drawing. And then you've got the client CPE, and CPE is a telecom term. It's customer premise equipment. That's what we mean when we say CPE. Now, there are very few reasons to go fastnet to Oracle Cloud if you're doing express route from your on-prem network into Azure. The real value of Azure is just the strength of the code, the support, the community, the partners, and the quality of the interfaces are just beautiful. And when you go to other cloud providers, it's not that way. I've done AWS terraforming, and I hate when I have to do terraforming in AWS. It is not clean like Azure is. What I mean by clean is you got your documentation is spot on, you can understand it, and it behaves the way it's supposed to. And there's very little, if any, experimental API crap in there. So with this particular deployment, I show an IPsec tunnel because there are very few organizations that need that kind of throughput into OCI. And you need to have that IPsec tunnel so you can manage the virtual machine databases, and so that you can also connect to OEM. I'm sorry, they rebranded it. It's called Cloud Control now because you still want Cloud Control. So you're going to still have some Oracle. I've done Oracle for hundreds and hundreds of years. Those Oracle components, they are not going away with multi-cloud. They are not going away when you move your database into the cloud. And now I'm done with my talk and talk, and I'm going to turn it over to Andrew. Andrew, are you still on the call? Have I put? I'm sorry? Andrew Fritz is an incredible software developer. He's worked in a variety of industries. We are lucky to have him. And he is, he's got the highest level of Oracle Cloud certification. So he's our deepest person on the bench with Oracle Cloud. And he's learning Azure. I'm deeper on the Azure, and we complement each other very well. Andrew, I hope I've introduced you well. Are you on the call?
I guess. Can you hear me?
Yes. So I'm going to stop presenting. Help. I see it. All right. And I'm going to maximize this and go on mute. Andrew, it's all your show.
Thank you. So I put together a few slides and just going to talk through them and the example. So everyone has probably seen the announcement of the service. And we mentioned Hank had this drawing as part of our presentation earlier. And when we go through, you can actually go through at the bottom of it and click this Get Started. I also gave a link to that here, which again will make the presentation available. But when you go through the sign up and actually link your account, you notice that I've already done that. So it just took me straight to the portal. And it looks like a lot like Azure interface by design. So even though it's hosted on Oracle servers, we can see kind of a more familiar icon structure and layout, and the skins feel the same. And typically, you can manage your subscription here and link or unlink it if you're exploring or you have multiple subscriptions to manage. You'll probably become familiar with this. And then you have just a simple interface to create database. And we could walk through it. It's fairly straightforward. You pick so it obviously has the integration with Azure. You can pick your resource group. And then your shape. So it's coming from the Oracle shape for your database. Your license, your version. And you'll actually see, I wanted to get to this point to show that that's wonderful. It actually has a drop down here that when working properly will give you a list of virtual networks available in Azure. At the moment, it's KO, so we're not going to get very far creating this. But that's okay, we can move on. We had hoped to show a deployment both from the Azure resource side and from the Oracle standpoint. And when we linked our accounts, we did see that the integration was nice enough to create some compartments for us over in Oracle. So we have the cloud link linked to our Azure account, and there's a child compartment that gets created, and there's actually a compartment created for the resource group that we're attempting to create the databases in. Unfortunately, that's as far as it gets at this point in time. I've opened 2 sub-1 tickets in the past 2 weeks, trying to get some support from the Oracle team as to what failed means, if they could give us a little deeper understanding of the error and what might be failing. But as of right now, we're just getting your deployment has failed. So we'll have to give an update once we've worked that out. But in the meantime, since we had just finished doing the manual deployment for the client and was the prototype for this, we can go. I went ahead and redid the in our cloud space. So that, if you're familiar with it, you've gone through either the Microsoft or Oracle training on it, you'll probably recognize some of these links. It's a pretty tried and true process, well documented. And it'll walk you through the prerequisites you need to build your environment. And pretty good step-by-step. And this is the Microsoft starting point, but you can likewise start from the Oracle side as well and see that you have really some good information about not only the high level but practical step-by-step setup. And what I found in Oracle, the A-Team blog is a very useful resource, and they have a nice blog post on the use cases for the interconnect. So I thought, why not use that to drive our review of the tech that we built specifically for this presentation. So you see on this slide, we have a lot going on here. I've given on the left the Azure components that we defined. So we start with the express route. We define the express route, and once we've defined the express route, it gives us the starting point for building our fast connect on the other side. So let's take a look at that and see what that looks like. So in Azure, when you create, Hank was mentioning you have to choose your SKU, and it really helps you define the factors that are going to influence your connection. So when you're building your express route, you're going to choose the bandwidth that you need, and of course your co-location. In this case, DC is paired with Oracle's US Ashburn. So we chose that, and it generated our service key. So once we have our express route defined and have generated our service key, we go over to the Oracle side of the house and we build our fast connect. So remember, the fast connect is our pipeline. It's on the other side of that switch from our express route. And it connects in through our dynamic routing gateway on the Oracle side. And that's where it reaches our virtual cloud network where our databases are created and our VMs. And we can have, from this hub, we could have many spokes throughout our Oracle architecture. So from that diagram, my fast connect properties, we'll see we also have entered partner service key. That was what was defined in our express route. So by entering that and configuring our BGP connectivity, we've defined both a primary and a secondary address for both sides of our connection. So we have on the Azure side or customer side, the primary connection and the secondary, as well as for Oracle. And you can see that in our network visualization over here on our Fast Connect. We actually have the primary, secondary listed. Likewise, on the Azure side, you will see them in the network. Right here, it's kind of small. Sorry for the eye chart. I don't know what it looks like in the room, but these are actually the addresses for Oracle as viewed from Azure. All right, so from Azure, once we've established that connection, so we define those BG ports and we establish our access. The tricky part is connecting your Azure networks to it. So you've got your express route sitting there, but you've got to do some routing work. Well attuned at doing the routing on the Oracle side. This was my second setup in Azure, so it was a long day figuring out how to do it, but the concepts are very much similar. The key here was defining this virtual network gateway with the type express route. So the virtual network gateway in our presentation, see it in our network topology. It established the connection both between our internal network using a gateway subnet and out to our express route and over to Oracle. So once we did that, we were cooking with Crisco. And that network topology here in the Azure side. Is as you would expect. Once you've done your routing, and likewise on Oracle, we had some routing to do it in our route tables for our virtual network where the database lives. So here you can see that our virtual network has a CIDR of 10.244.0.016. So we actually have two subnets with that, a public and a private, 0 and a 1. So in those route tables, we had to define our routes out through the dynamic routing gateway, which is our link to the Fast Connect on the Oracle side. Sometimes it's easier to click than others. It's nothing too deep on this, just wanted to touch on what we had to do. sorry. So our Azure Net CIDR is 10.2.0.0/16. And we set up a route out from there. We actually had another subnet we didn't complete on the Azure side. But in doing this routing up to our DRG, we can see that the DRG route tables are auto-generated. We don't actually define anything there. It picks up its route rules from the routing that is done on the network. So the fact that the network is routing these down to our VCN and up to the DRG circuit, which goes out to our express route. So now that we had the network set up, let's show you the empty compartment. We have another compartment built for our database system, and I just created it on the same VCN that we have set up. And we can actually see that it doesn't have any public access. So our private IP address is here, and that's shown down here in the eye chart. And so the VM over in Azure is connected through the express route and fast connect bridge, and it's routed all the way through to our VCN. We got a simple security list on each side where we've opened up the ports so that we're able to connect. And now we bring up you can tell by the name, it's the VM in the picture, but you can also see our IP address is in our 10.2.0.0.16 range. We have 10.2.0.5. And over here, I am actually in, notice that our database doesn't have a public IP address. So I created just a virtual machine that I could give a public IP address and connect to. So this virtual machine in Oracle, it lives in the public subnet. If we look at our network, remember that we had two. We have the private subnet where our database lives, and we have a public subnet, and that is routed out to the internet through an internet gateway definition. So we can actually see our instance has a public IP that is what has enabled me to connect to it. Right here, 150. Also has a private IP in our .0 subnet, as opposed to our database being in .1. So internally, I can connect to the database directly from that subnet. And as you will see, I can also ping Azure, which is their 10.2.0.5. address. And we are seeing right now a little heavier latency than earlier, but still ping is coming back pretty quick. As opposed to pinging locally in Oracle. There's, as Hank mentioned, there's still latency even when you're in the same cloud data center within Oracle's. But it's pretty darn quick. Really interesting thing is from Azure. We're seeing less than 2 millisecond delays going over. And we've actually seen this hold up to testing the applications, the ERP test applications that we have deployed in Azure with our database running in OCI. Of course, you don't have to just ping. I've set up the shell so you can actually connect from Azure and do any database work that you want to get done. Was there any questions? I went through it kind of quick. If you want to drill down on any particular component, you can ask a question in the chat. We can open up the mic, talk a little bit about it.
I'd like to mention that Andrew worked most of the night to get this ready for you. And I'm very grateful. Thank you, Andrew.
It was my pleasure. It's what I love to do. It's good when you can have a job doing what you love doing.
So let's open it up to questions. This is your opportunity to pick the brains of the people, two of the people who are part of this pilot. Yes, sir. Sure. So the question is, could I explain why there's a cost delta between the automatic versus the manual? First of all, that applies only when you're doing more than one region with the product. If you're doing a single region, and I don't know why you would do a single region because you want the DR. The cost delta exists if you're with a manual deployment because you can select a slower express route gateway and a slower virtual network gateway instead of the ultra premium or the SKU is on the Azure side. And depending on how many of those you have and how many regions, that can be a lot of money saved. In the case of this particular client, that was $250,000 in savings over 5 years. Now, the downside of that is that you've got to deal with the manual complexity, number one. Number two, you've got to retain that talent, and that talent, it has to stay fresh. And number three, if you really do have to fail over, you're paying egress charges. So like anything else in engineering and design, there are compromises. And the question that you would have to determine as the enterprise architect is that for the customer an acceptable compromise? We like questions. Wow, crickets are talking loud. Yes.
I'll go for it. It might be, I don't want to cut somebody else off. Is there somebody over here?
Go ahead.
Okay. If you're using this deal with Oracle and Azure, can you compare the results of savings, the advantages with what the alternatives are? And why specifically you come out ahead if you're presenting this to a higher level in the organization?
That's a really good question. Let me repeat it, especially, let me paraphrase that. So compared to other solutions. Here. Rephrase. Talk right into it.
I'll try it again. When you make decisions, you've got to, elucidate the alternatives and then figure out which ones are the best. So how would you identify the alternatives of your solution versus the others so you could present it to the next level up to explain why there are advantages to you and what if the benefits are? This isn't supposed to be a sales thing, but it is supposed to be an information thing.
Yes.
Is that clear enough?
Yes, it is. Thank you. So how do we sell this to senior management? That's really what you're driving at. First of all, a book, To Sell is Human by Professor Pink. If you haven't read it, pick it up because everyone is a salesperson. What are the alternative solutions? First of all, for an apple-to-apple solution, there is not an alternative solution. There are third-party solutions for AWS to Azure, but the latency is a real problem. So for cloud-to-cloud provider with this kind of integration, and you saw that Andrew working through the night got some of the automatic part of the solution working, not all of it because you couldn't provision the database, but everything else you saw in Azure, you could see the OCI stats and vice versa. That's part of the integration. Now, so how do you compare it when you're comparing apples to an apple that fell off the tree, aka the third-party solution? Well, first of all, you point out that apple fell off the tree and some marketer painted it and put it back up on the tree, and you don't want to pick that apple. So you're comparing to on-prem and you're comparing to, say, on-prem hybrid, thinking BitBlue and their marketing. And you're also comparing to an all one cloud provider solution and what it's going to cost. In the case with this client, we were tasked to compare on-prem, because they're a large institution, they're part of a system in a sizable state in the South. And so there's a system, and they could have done the DR within the system. And as a matter of fact, that's how they're doing DR right now, until we cut them over a few months for production. And so that was one of the comparators. But the other comparator for cloud other solutions was to point out, well, yeah, IBM's doing this great marketing with hybrid cloud. But when you really look at it, it was their acquisition of software. And it's a bunch of open source that really doesn't have the robustness of the Microsoft system. That's the people, the knowledge, the documentation, the collaboration with the partners, the research, the bleeding edge research. That's pretty powerful. And other cloud providers don't have that. And when you look at AWS, it's very open source AWS when you do, like when you're doing terraforming and other kind of work. You don't have the beauty of that Azure portal, which I love so much. And what do I love about the Azure portal? It saves me time. I get my work done with less effort, and I make my boss look good. So now I also, when I sell it, CFO, you're going to save $2.4 million in 5 years, and you're going to realize that investment in 2 years and 5 months. And I've done this enough. I'm talking we as an organization at Kent Cloud and David Kent companies. We've done this enough where we have integrity. And so if you've got integrity with your bosses, you can show them the numbers, lay it all out, and let your peers pick it apart. And you want that. You want to have that constructive, positive criticism, and I call it a constructive, a positive argument. You want to have a positive argument. Make sure it's right before you actually go in front of the board or go in front of the senior vice president and present. You want to have consensus, not only within IT, but you want to reach out to your functional areas, to your CFO, to other people in the organization who are not IT, and you want to build consensus. So that when it gets in front of the executives in C-suite, everybody's shaking their head this way, not this way. Does that help you?
Yeah.
You had a question.
Well, I had also same question, and yeah, so like Microsoft SQL Server or maybe something like that. This is what actually I was also thinking. And the other thing is, you showed the cloud places like what you showed in the beginning, the what you call it, regions.
Yes.
You showed the Microsoft regions, or it will use the Azure regions, or the Oracle has its own regions and just Microsoft is just giving the platform and exposing the services to Azure portal, something like that. Or these services are within the Microsoft data centers, like, or Oracle has their own data centers.
Yes, they do. Both, they're frenemies is the term. Friends that are enemies. And so Oracle and Microsoft are fierce competitors, but where it makes sense, they've partnered, and this is a good example of that. So yes, there are competing services. But fact of the matter is most of us work in a Microsoft world. We are familiar with the company, we are familiar with the products. We know how to get support so we can be efficient with our jobs. I'll tell you though, that Oracle database had it really fast in the cloud.
Is there any benchmark like related with the Oracle, SQL and all, something like that? Do you have any kind of benchmark with you?
We have benchmarks, but typically what we do, and I've done some research on this. It's like one of my other, remember, I talked about two things that I do. One of them is queuing dynamics, mathematics. And we could, if you email me, I can send you the research papers that are the basis for a lot of my math. What I do is I take actual performance data from existing on-prem hardware, and then I run that through a mathematical model that factors the relative performance of the on-prem processor farm to the relative performance to the cloud processor, because there is a delta. And I also take into account with math, when we go to the cloud, we're going to be running in what we call a steady, what Little, Little's law, what Little calls a steady state machine, where work that is egresses the machine without delay. There's no waste. So in Oracle Cloud, with the Oracle Virtual Machine Database, when your application is properly tuned, and when you properly quantified and qualified the workload, you can achieve that steady state machine operation at about 95% of your operations. Does that help you?
The minimum requirement to use this Oracle. Like for example, most of our stuff, we are right now currently we are using SQL, like manage instances or sometimes single servers, something like that. So what are the minimum requirements so we can tell, okay, now the SQL server is not working and we have to move to the Oracle and something like that? What would be the minimum requirements? Like if you go to the client and client asks you, client might ask, why I'm going with Oracle? Like you have some cheaper solution kind of.
Well, the question is what are the minimum requirements for Oracle databases? That's really an application architectural question because there are very significant differences between SQL, MS SQL and Oracle database, but there are stark differences from an application developer perspective. First question I would ask is I would go back to my developers and say, you know, I know a lot of companies who are big, who are doing a lot of really powerful stuff on enterprise SQL. Why can't we do that? I would turn that around and say, I'd look at that again and make sure that that is something that I have to do. Because if I'm hitting the wall with enterprise SQL, and if I'm hitting the physical constraints of a relational database system, then I need to be thinking about NoSQL. And we don't have time to talk about that kind of an application database architecture tonight. I'm familiar with MSQL and NoSQL from an architectural perspective, but frankly, that's where you might have to go.
Most of our clients with situation with Oracle, the Oracle database running in OCI, the application, the application is dictating that it requires for backend. That answer your question? I mean, it's not a matter of minimum requirements to go to Oracle versus SQL Server. Not about that. It's where the Oracle database backend is required.
Yeah, typically if it's a new application and if it's big data, it's being developed on an open source database these days, like a NoSQL type database, but not always. You had a question, sir?
Yeah, so the examples you gave were around disaster recoveries. Simpler cases like you're using Power BI and Azure and you have an Oracle ERP on OCI. Would you go through these steps for these similar steps if you want to connect Power BI to OCI and Oracle?
Yes. So it was Power BI to Oracle. Would we go through the similar steps? Yes, you would. Apex, same way. More questions? Well, I want to thank, yes, sir.
I have a question about DevOps of this. I think you made a few comments about, did you use Terraform to set this up and what does that look like?
Okay, so the question was, how did we implement this with DevOps? First of all, remember DevOps is as much about re-engineering the organization and the organization's culture. It's more about culture and changing the culture and then picking the tools to be successful. We used a combination of tools. For the demo, this was done with the OCI and the Azure user interface, the GUIs. For the client, on the Azure side, it was done with Terraform. And on the OCI side, it was done with a combination of wrappers that we wrote directly to the Python APIs, which we consider to be open source because you can see the APIs online, so there's nothing to hide there. As well as when necessary, there are certain things on both the Azure and the Oracle side where the UI had to be used. Because in the back end of a lot of that, there's this huge amount of terraforming that's going on that just thousands and thousands of man hours of work that it would not be worth it to try and write a Terraform script yourself to do that. There's certain things. Does that help you?
Yes, I was wondering about that as well, if you use the combination of, let's say, the Azure CLI, to do some of those things, but it sounds like you just use the portal to do the glue.
You can do all of it with the portal. But to have efficiency and to be efficient, consistent, and to be as defect-free as possible, you want to do as much as you can with infrastructure as code as possible. In a DevOps model, where that code and the knowledge of that code is in one place, you have a change in personnel, someone else with the same skill sets can come in and look at the code and figure out. You don't want to have any Hankware or Daveware, where if Dave leaves the organization, now nobody can support you. That's just not acceptable. More questions? These are good questions. Thank you. Thank you very much. I'm going to turn it over to Adam.